we will solve the numerical problem. First question is, if angular displacement is the function of time. Function of time is angular displacement is related with time. As time changes, angular displacement changes. So this is the relation. Then what we have to find? The angular velocity in 3 seconds and at 3 seconds. When I say in 3 seconds means duration is given 0 to 3 seconds. Means we want average angular velocity. When I talk about at 3 seconds means I want instantaneous angular velocity. Now we will proceed for solution. So what is given? Theta is equal to 2t square plus 4t plus 5. This is the relation angular displacement and time. So we will find two displacements at two different times. At initial stage, what was the angular displacement that we will find? Means suppose at theta at t is equal to 0. It is theta 1. So putting t is equal to 0, we will get 0 plus 0 plus 5, that is 5 radians. Right? And then we will find theta at t is equal to 3 seconds. So it is theta 2 I will write. That is 2 into 3 square plus 4 into 3 plus 5. That is equal to 18 plus 12 plus 5. That is equal to 35 radians. So angular displacement at two different time I have taken. Therefore, omega average is equal to theta 2 minus theta 1 by t. That is delta theta upon delta t. Delta t means 3 seconds and delta theta means theta 2 minus theta 1. So we will write 35 minus 5 by 3. That is 30 by 3. That is 10 radians per second. So we got average angular velocity means first part. So first part is over. We will go for the second part, that at 3 seconds means instantaneous angular velocity is needed. So we will differentiate this. So therefore d theta upon dt. If we are differentiating this with respect to t, then 2t square, that is 4t plus 4. The differentiation of t square is 2t. The differentiation etc. I have already told you. If you see my video for mathematical tools, तो उसमें आपको दिखेगा कि t a x to the power n का differentiation क्या होता है? n x to the power n minus 1. So t square with respect to t is 2t, the 2 into 2 4t, and t to the power 1 differentiation is 1. This is 4t plus 4. Now we want this. This is what? It is omega. Therefore, d theta upon dt at t is equal to 3 seconds हमको निकालना है. तो 4 into 3 plus 4. ऐसे लिखते हैं. At this omega we want at t is equal to 3. d theta by dt at t is equal to 3. So put the value of t over here. So we will get 12 plus 4, that is 16 radians per second. So what do we observe? Omega average is 10 and instantaneous angular velocity is 16 radians per second. So these two are not equal, and this is, we will simply write, therefore omega is equal to 16 radians per second. So this is the answer, and this is for average. So concept is clear. Displacement is given in terms of t, then we can find at duration is given, then we can find theta 2 minus theta 1. If at particular time is needed, particular instant is needed, then we will find the instantaneous angular velocity. There is another question. What is given? Object is in circular motion, right? Radius is given 2 meter. Then at time 1 second, what will be the tangential acceleration, radial acceleration, and net acceleration? A net, simply A. So we will proceed. We know the formula for all. So in that accordance we will go. First we will find the angular velocity as t is equal to 1 second. So given theta is equal to t cube plus 2, therefore d theta upon dt is equal to 3t square. It is a constant now. Derivative of constant is 0. So this is omega. Therefore omega is equal to d theta upon dt at t is equal to 1. That is equal to how much? 3 into 1, that is equal to 3 radians per second. Now we'll find acceleration, that is angular acceleration. So differentiate omega once, then we will find the angular acceleration. Therefore d omega upon dt is equal to, this is of course, this is equal to omega. So if you differentiate this, you will get 60. Therefore, and this is alpha. Therefore d omega upon dt at t is equal to 1, that is equal to alpha, that is 6 into 1, that is 6 radians per second square. So two things we got. We got omega and alpha. So radius of this circular path is given 2 meters. Then we can find tangential acceleration and the radial acceleration. We know tangential acceleration at is equal to c. at is equal to alpha into r by magnitude. So alpha into r. What is alpha? 6 radians per second square, and this is 2 meters. So that is equal to, that is 12 meters per second square. This is the tangential acceleration. And we know angular radial acceleration, or it is called centripetal acceleration also. Radial acceleration is towards the center, then it is called a centripetal acceleration as well, and it is denoted by AC. That is equally true. That is r omega square. We will write in terms of omega because omega is known. So r is 2, omega 3 square, that is 18 meters per second square. AT is known and AR is known. Then we can find A, that is net acceleration, is equal to AT square plus AR square, that is equal to, AT square means 12 square plus, that is 18 square. A is equal to under root 144 plus 324, that is equal to under root 6. We can find the square root, that is A is equal to under root 468 meters per second square. This is the answer. So method is clear. So this is the solution for this question. Question is, it is one object is in circular motion and the radius of the circular path is 8.1 meter and velocity is related with time this way, v is equal to t square. Then at t is equal to 3 seconds, we have to find the tangential acceleration, radial acceleration and the net acceleration. This is the question. So what is given? Velocity is the function of t and relation is given. Now we will differentiate this velocity with respect to t. We will get therefore dv upon dt, that is 2t, and dv upon dt is what? This is the tangential acceleration and this is tangential acceleration at. So at is equal to dv upon dt at time t is equal to 3 seconds. This we have to find. So since this is varying, means acceleration, tangential acceleration is varying with time. So at 3 seconds, what is the tangential acceleration? That is 2 into 3, that is 6 meters per second square. This is the tangential acceleration at t is equal to 3 seconds. Now we will find radial acceleration or centripetal acceleration. So at t is equal to 3 seconds, what is the magnitude of velocity we'll find? Therefore, velocity at t is equal to 3 seconds is equal to 3 square, that is 9 meters per second, and we know AR is equal to V square by R, that is 9 square upon radius is 8.1 meter. So 8.1, that is 81 upon 8.1, that is equal to 10 meters per second. So AT is known, AR is known, at t is equal to 3 seconds, then we can find A, that is under root AT square plus AR square, that is AT square means it is 36 plus AR square, that is 100, that is under root 136. Therefore, A is equal to under root 136. It can further be simplified. 136 will be factorized. That is, this can be related to under root 34 meters per second square. This is the net acceleration or simply acceleration for this kind of circular motion. Next question. An object is revolving with uniform speed in a circular path of radius 10 centimeter and time taken to complete one complete revolution, that is cycle. One cycle is pi seconds. Then what is AR? So here what we have to do, what is AR? That is V square by R. R is known, we are supposed to find V, velocity. So what is velocity? Suppose it takes time 5 seconds. So total distance covered is, velocity is V, right, into pi. This much distance it covers. So total distance is how much? That is 2 pi r. Total length, that is velocity into time, is 2 pi r. Therefore, velocity is equal to 2 pi r upon pi. This pi will go, we will get 2r. Therefore, velocity is equal to 2 into 10, that is 20 centimeters per second, because it is 10 centimeters. Velocity is known, so we can find AR. So AR is equal to V square upon T, right? So V square by R. So V square means 20 square upon R is 10, that is 400 by 10, that is 40 centimeters per second square. This is the answer. AR is equal to 40 centimeters per second square. This is the answer. So question is of different kind. Simply we have to look at it and find what is required, that is to be found, and what data is given, that we have to write and accordingly find the solution. Two objects are there, A and B. From the initial stage over here, means at t is equal to 0, they are projected in two different directions, opposite directions, and which are moving along this circular path. A is moving like this, B is moving like this. So after what time they will collide? When the velocity of A is 3 meters per second, velocity of B is 7 meters per second. After what time they will collide? So when it is moving with 7 meters per second, with 3 meters, then after what time they will collide? So let they collide after time t seconds. Means they started after time t, they will collide somewhere here, suppose. Here they are colliding. This is A and this is B. And the time taken by this A and by this time will be same in both the cases. So total distance covered by both will be how much? It is 2 pi r. The distance covered by this will be how much? Speed is 3 meters per second. Speed into time, that is VA into T plus VB into T is equal to total distance is 2 pi r. Then some distance will be covered by this, and some distance will be covered by this, and along this total distance is VA into T. That is uniform speed it is going. Uniform speed B is also going. So VA into T is equal to VB into T. Total distance, this plus this. So VA is 3, therefore 3 into T plus 7 into T is equal to 2 pi R is 5 meters. So therefore T into 10, right, is equal to 2 pi into 5. So 10 with 5 into 10 will go. So T is equal to 5 pi second. That is equal to approximately 3.14 seconds. During this time they will collide. And we are asked T is equal to what? And ARA, that is equal to what? Means what is the radial acceleration of A? So that too we can find. ARA is equal to VA square upon R. That is equal to VA is 3. So 3 square, R is 5. That is 9 by 5, and that is equal to 2.25 meters per second square. Yes, therefore ARA is equal to 2.25 meters per second square. This is the radial acceleration or centripetal acceleration of A, right? Because V is constant, everywhere we will have the same radial acceleration towards the center. So this way I have solved a few questions. So I hope you have understood, and we will meet next time. We will solve more problems in this, and I will ask you to practice with the more problems using this formula, and concept should be made clear. How to apply this formula should be known to you, and आशा करता हूँ कि आप जरूर करेंगे. So next time हम मिलेंगे कुछ difficult problems लेकर के, further difficult problems लेकर के. Variety of things will be there in that. So till then, wish you all the best. Take care of you and be fit.